once I've got these all trimmed up, I'm just going to bare the ends. And you don't want too much of the wire sticking out. You're going to put in like that. So again, measure here how far that wire is going to go in. And then just take the end off. So we're just putting the conductors in now. I'm going to put each one into their appropriate spot. So put the ground into the ground, the green into the ground, the hot into the hot, or the black into the hot or live. And then all we've got left is the little white or return. Remember, we're dealing with AC here, so all of the actual incoming energy is traveling backwards and forwards on the black line. Okay, so we take those guys there and we close them up, and then we're going to push that cable back. Now, before we do that, this is where we decide if by chance you're thinking that the glue inside the tube is going to make a difference, then you want to try it with the glue, without the glue. I already know that that's not the case. Yes, the glue must make some sort of little bit of difference, but it's not a large audible one. It's not the technology behind this, obviously. If it was, shame on us, eh? but anyways, what we're going to be doing here, just going to borrow a couple of connectors out of this guy here, or a couple screws, is sealing up this first end. So what I'm going to do, you want to have a really good fill. So this is a very hot glue gun, and I'm compressing this so that the glue goes well down inside of here. Okay, you want that to come down nice and far. Then as you put this together, you're going to push this back, which can create an air cavity. So fill that cavity with glue as you push this back. Okay, like that there. Now, the other thing that you can do, you want to make sure that there's absolutely no gaps in here, because you don't want that material to be coming back out later. So we're going to pull this up nice and tight, and just kind of glue inside here, and make sure that we've got a really good seal. And then close this up and put our screws back in. Okay, and we want the glue, as the glue is quite hot, it will still continue to have a little bit of a runny consistency to it. We want that glue. You know, we've got cable guys that make this look really easy. I haven't done it in quite a while, and so I might make a bit more of a mess of it than I should. That glue can be really hot, by the way. I'm used to touching it with my fingers, so be careful that you don't burn yourself if you try that at home. Now, we're just going to let that set up. We want that glue to set up so that none of that material is going to be able to fall through. So I'm just going to set it on my CD rack there for a second to set up, and then we'll be right back with you. So now we're back. Our glue has set up and dried, and we're ready to build the cable. Now, I have to point out that if you don't have a CD rack like this to hold your cable on, you're not going to be able to build a Power 3. Unfortunately, the rack is required in order to be able to build your new Power 3. Anyways, so here we go. We're going to take the other end now, and we're going to put on the other connector. Now, you want to do this before you actually put your fill material in, because you want to take a listen to the difference between the cable with the fill material and without the fill material. So as you go ahead and put your other connector on, one of the things I want to show you is that right here inside they'll always be marked so that you'll know your live, your neutral, and your ground. The ground is always the little guy here sitting in the middle at the center, and then your hot is always consistent. So you can follow the same pattern as you had on your original one. So the hot connector is this guy over here, just the same as it is right here, okay? That's always brass where the nickel is on the return. So make sure that you follow the labels and do it properly. If you don't, if you get some of these wrong, you can cause yourself a bit of a problem. One, you can wire it out of electrical phase, so you can put the neutral into the hot. Cable will still work just fine, although you shouldn't do it. The other possibility is to actually get the ground into the hot, which would be fun. You can mess it up pretty badly, so just pay attention to that. So I'm just measuring this up here. And it's okay to, cut it a little bit long first and then trim the excess after you've done a second measurement. That's better than doing it the other way around and finding out you don't have quite enough conductor left. Okay, so now we're going to bear those conductors down on the end. And we put the conductors through. Now this is the thing, the bigger the wire you have, the greater the amount of challenge. So this is one of the things that we run into at Virtual Dynamics here. As you know, we get into the use of some really large wires, and they cause for really amazing problems in trying to actually make a really good connection. So we spend years at it trying to make sure that we can make it look simple. Of course, that's not my job, not anymore anyways. My job is to amuse people on YouTube. Now, if you're wondering why a cable costs thousands of dollars, well, if you bought one from that I made personally, it's because there's thousands of hours of labor that go into actually assembling a cable like this and putting on a simple conductor end or connector. Aren't you glad that I no longer am in production? So, we've got everything fastened in there nice and tight. We've moved the ground wire over to this side. I'm just going to move it a little bit more to make sure it's good and out of the way. If you do something like this, like I am with the pliers, just make sure that you check your dielectric to make sure that you haven't caused any problems to your dielectric, which is the plastic material that sits outside the conductor. You don't want there to be any possibilities of a short. Now we're going to put on the strain relief. Again, I'm going to move the ground over. And once the strain relief has went into place, you put your connector cap over top. Now, there's a little piece here that you can feed the wire through first, and if you feed that in through first on the shirter, down here it'll help to be able to press your glue in, and then you can actually fill that too with glue. And now on this one here, I'm going to actually leave that out. You know why? Because I forgot to put it in. Don't do that when you're building your cable. Now you don't want to torque this. You want to torque all your screws fairly tight, except for this one, because you don't want to crack the plastic. Okay, so basically what you have now is a cable that's you're ready to listen to. You can take this guy and plug it in. I'm going to recommend on your CD player or your CD transport. And the reason why that is because although your amplifier actually draws more current, and a lot of people think you should put it there, if you put your cable on the CD transport, if it's going to do its job properly, that means it's actually going to clean the incoming signal. or the AC energy and make it so that the CD player has a cleaner output. Okay, so that's what we're hoping that the cable does. Now, when we tested it, what we noted is that it increased the total amount of slew rate. So there's actually a faster rate of processing of speed of energy as it comes through. And it's slew rate. If you want to know more about it, look it up. But the bottom line is, it's one way that we can measure and know if there's an actual difference or not. Okay, so this is slew rate primarily that we're measuring to see if there's any change when we put the new cable in. Now, let's say you don't believe that this cable can make a measured difference in slew rate. Then if you're knowledgeable enough to know what that is, you may be knowledgeable enough to measure it, so measure it for yourself, and that's the way you can find out. Or if you know somebody that can measure it for you, take it down to them and have them measure.